What's up guys, this is Massey, welcome to another video. In this video I want to show you the cross product of vectors. This is the formula for finding the cross product of vectors, which is u cross v equals to the magnitude of u times magnitude of v times sine theta. And the theta is between the angle between u and v. If you want to show you the direction of the answer to this question, we're gonna use the right hand rule. For example, the product of u and v is gonna be like that. We place the right hand in here, cross it, and it's gonna go outward. That's the answer to this cross product. If we have v times u, then it's gonna be the other way around. It's gonna be v, u, and it's gonna be inward. So when you want to find it, it's gonna be u that v equals to u times v times sine 40. That will be 30 times 20 times sine 40. 600 times sine 40. That will be 385.67. This is going to be the magnitude, but if we have u that v, the magnitude is the same thing, but it's gonna come outward. If we do v cross u, it's gonna be inward with the same magnitude. Now here it says let vector a is a1, a2, a3, and vector b is b1, b2, b3. The cross product of a and b is a2, b3 minus a3, b2. And the y component is going to be a3 b1 minus b3 a1, and the third component is going to be a1 b2 minus a2 b1. So consider the vectors a is 7, 1, negative 2, b is 4, 3, and 6, and c is negative 1, 2, and 4. Find out the cross product of a and b. So we can say a2b3 minus a3b2, a3b1 minus a1b3, and then we have a1b2 minus a2b1. a2b3 is 7 times 6 minus negative 2 times 3. It's going to be 42 plus 6, that's going to be 48. A3 is negative 2, B1 is 4, minus A1 is 7, B3 is 6. It's going to be negative 8 minus 42 is going to be negative 50. A1, B2, A2 is 1, B1 is 4. So it's going to be 21 minus 4, that will be 17. So we have 48, negative 50, and 17. Next one is going to be confirm that the cross product of a and b is orthogonal to a and b. So basically we need to prove that the cross product of a and b dot a equals to 0, and cross product of a and b is it's going to be 0 as well. So we already found that, which is 48, negative 50, and 17. Dot a has to be 0. A is 7, 1, and negative 2. So it's going to be 48 times 7 plus negative 50 times 1 plus 17 times negative 2. That's going to be 48 times 7. There was a little mistake, I've just fixed it. Instead of 1, I wrote 7 because A2 is 1, not 7. So that's why I fixed it here. Is 6 plus 6 is going to be 12. So I fixed this one here. So we have 12 times 7 plus negative 50 times 1, 17 times negative 2 is going to be 84 minus 50 minus 34, that will be equal to 0. So that is correct. It means that the cross product of A and B and A are orthogonal. Let's check the second one. It's going to be 12 times B1, which is 4, plus negative 50 times 3, plus 17 times 6. So we have 48 minus 150 plus 17 times 6 is 102. That's going to be also 0. So you can say the cross product of A and B is orthogonal to B as well. Then here it says, determine A, the cross product of A and B, B plus C, and the cross product of A and B plus the cross product of A and C. Find out these two and compare them. So we can say, I'm gonna write all of them again here. A is 7, 1, and negative 2. B is 4, 3, and 6. And C is negative 1, 2, and 4. So we have B plus C is 3, 5, and 10. So the cross product of these two it will be A2, which is 1 times B3, 10, minus A3, which is negative 2 times 2, 5. Then we have A3, negative 2 times B1, which is 3, minus B3A1. B3 is 10, A1 is 7. Then the last component is going to be A1, B2. A1 is 7, B2 is 5, minus 1 times 3. So that will be 10 plus 10 is 20. Negative 6 and negative 70 is going to be negative 76. And 35 minus 3 is going to be 32. Now let's find out the cross product of these two. The cross product of AB will be A2, B3. So 1, 6 minus A3, B2, negative 3, 3. A3, B1, negative 2, 4, minus B3, A1, A1, B2, A2, B1. So it's going to be 6 plus 6, 12. Negative 8 minus 42 is negative 50. And we have 21 minus 4. That will be 17. Now we can find the cross product of AC. A times 1 times 4 minus negative 2 times 2, negative 2 times negative 1 minus four times 7, then 7 times 2 minus 1 times negative 1. So then it will be 4 plus 4 is going to be 8. Then we have 2 minus 28 is going to be negative 26. And here we have 14 plus 1 is going to be 15. When you add them, 8 plus 20, 12 is 20. Negative 26 and negative 50 is negative 76. 15 plus 17 is going to be 32. As you see here, this vector and this vector are the same. So it means that the cross product of A and B plus C is the same as the cross product of A and B plus the cross product of A and C. Now next one. We need to find out A plus B, cross product of A plus B and C, and then cross product of A and C plus B and C. A plus B will be 11, 4, and 4. And C is negative 1, 2, and 4. So A plus B cross product C, that will be 4 times 4 minus 4 times 2, 4 times 2 minus, that's negative 1, not 2, negative 1 times 11 times 4. Then we have 11 times 2 minus 4 times negative 1. So let's simplify. We have 16 minus 8, negative 4 and negative 44. 22 plus 4, that make it 8, negative 48, 26. Now the cross product of A and C we already found out here. 8, negative 26, and 15. Now I need to find out the cross product of B and C. It's gonna be, the cross product of B and C will be 3 times 4 minus 6 times 2 6 times negative 1 minus 4 times 4. Then we have 4 times 2 minus 3 times negative 1. That will be 12 minus 12, negative 6 minus 16, 8 plus 3. It's going to be 0, minus 22, and 11. So when you add these two, 0 and 8 is 8. Negative 22 and negative 26 is going to be negative 48. 15 and 11 is going to be 26. Now if you compare this one with this one, we're going to say we have the same thing. So we can conclude that the cross product of A plus B and C equals to the cross product of A and C plus the cross product of B and C. Now let's take a look to the properties of the cross product. For any vector u, v, and w, and any scalar k, which belongs to R, the cross product of u and v equals to negative v and u. And also we can say the cross product of u and v plus w equals to the cross product of u and v plus the cross product of u and w. And here we can say the cross product of u plus v and w equals to the cross product of u and w plus the cross product of v and w. If u and v are non-zero and the cross product of u and v is 0, and if and only if there is a scalar m belongs to R such that u is equal to m dot v. It means that if we have two vectors u and v and both of them are non-zero, if the cross product of u and v is 0, we can say that these two vectors are collinear. Next one, k dot the cross product of u and v equals to the cross product of ku and v, and it is equal to the cross product of u and kv. Let's see the next example. It says determine the area of the parallelogram defined by the vectors u as 4, 5, 2 and v 3, 2, 7. You can say cross product of u and v so that will be 5 times 7 minus 2 times 2, 2 times 3 minus 7 times 4. Then we have 4 times 2 minus 5 times 3. So that will be 35 minus 4, 6 minus 28, and 8 minus 15. When you simplify, that will be 31, negative 22, and negative 7. So when you want to find the magnitude, it's going to be 31 squared plus negative 22 squared plus negative 7 squared. That will be 38.65. Now it says determine the angle. We can say sine theta equals to cross product of u and v divided by the magnitude of u times the magnitude of v. That would be 38.65. And here we have 4 squared plus 5 squared plus 2 squared times 3 squared plus 2 squared plus 7 squared. Which is going to be 38.65 square root of 45 times 9 plus 4 times 49 plus 49, so 62. So square root of 62 times square root of 45. Can say sine theta equals to 38.65 divided by 52.82. So theta will be sine inverse of 38.65 divided by 52 divided by 82. That will be 0.7317. 0.717. That will be 47 degrees. Next one, it says determine the cross product of u and v. The cross product of u and v will be the magnitude of u times magnitude of v times sine 55. So it's going to be 80 times 60 times sine 55. That will be 393193. Next one, magnitude of u times magnitude of v times sine 164. That will be 112 times 128 times sine 164. That's going to be 395153. Next, it says determine the cross product of a and b, and then the cross product of b and a for each pair of vectors. So we can say a and b will be, we have the formula will be a2b3 minus a3b2, a3b1 minus b3a1, a1b2 minus a2b1. So that will be negative 2 times 6 minus 9 times 1. A3 is 9 times B1 minus B3, 6 times A1. A1 is 3, B2 is 1, minus A2 is negative 2, B1 is 1. So that will be negative 12 minus 9. Here we have 9 minus 18, and here we have 3 plus 2. That make it as negative 21, negative 9, and 5. Now let's do the other way around. Cross product of B and A. It's going to be B2A3 minus B3A2, B3A1 minus A3B1. Then B1A2 minus B2A1. So we have B2 is 1, A3 is 9, B3 is 6, A2 is negative 2, B3 is 6, A1 is 3, minus A3 is 9, B1 is 1, B1 is 1, A2 is negative 2, minus B2 is 1, A1 is 3. So we have 9 plus 12, 21. 18 minus 9 is going to be 9. And here we have 2 minus 3. Negative 2 and negative 3, which is negative 5. So if you compare here we have negative 21, here we have positive 21. Here we have negative 9, positive 9, 5, and negative 9. So we can say the cross product of A and B and the cross product of B and A are the same magnitude, but they have two different signs. So in this example, again, we need to do the same thing, the cross product of A and B, 6, 3, 2, and negative 5, 5, and 9. So we will have A2B3 minus A3B2, A3B1 minus B3A1. Then we have A1B2, A2B1. So we have 27 minus 10, negative 10 minus 54, 30 plus 15. So that will be 17 minus 64, 45. On the other hand, we have the cross product of B and A. That will be B2A3 minus B3A2, B3A1 minus A3B1. Then we have B1A2, B2A1. So it's going to be 10 minus 27, 54 plus 10, negative 15 and negative 30. That will be negative 17, that's 64, and here we have negative 45. Again, here we have 17, negative 17, negative 64, 64, 45, and negative 45. Next one, we have A is negative 8, 10, and 3. B is 2, 0, and 5. So cross product of A and B will be A2B3, A3B2, A3B1, B3A1, A1B2, A2B1. That will be 50 minus 0, 6 plus 40 minus 20. So that will be 50, 46 minus 20. So we have B and A. B2A3 minus B3A2, B3A1 minus A3B1, B1A2 minus B2A1. So we will have negative 50, negative 40 minus 6, 20. So that will be negative 50 minus 46, 20. So again, 50, negative 50, 46, negative 46, negative 20, positive 20. Now here it says, for each pair of vectors, confirm that the cross product of u and v is orthogonal to A and V. So let's find out the cross product of u and v. That will be u2v3 minus u3v2, u3v1 minus u1v3, u1v2 minus u2v1. So now that will be u2 is negative 3, v3 is 2, minus u3 is 7, v2 is 6, u3 is 7, v1 is negative 1, minus u1 is 5, v3 is 2, u1 is 5, v2 is 6, u2 is negative 3, v1 is negative 1. That makes it as negative 6 minus 42, negative 7 minus 10, 30 plus 3. So it's going to be negative 48, negative 17, 33. So it says find out if it's orthogonal to u and v. So it's going to be negative 48 times 5 plus negative 3 times negative 17 plus 33 times 7. So when you correct it here, I just corrected here, that's instead of plus has to be minus. So the answer is 27. So negative 48 times 5 minus 3 times negative 17, 27 times 7 is going to be 0. So it means that u is orthogonal to u cross v. Now let's check that if v dot u cross v is 0. So that will be negative 48 times negative 1 plus negative 17 times 6 plus 2 times 27. That's going to be 48 minus 17 times 6 is 102. Here we have 54. So we have 102 minus 54 minus 48. That's going to be 0 as well. So it means that u and v, both of them are orthogonal to the cross product of uv. Next one, it says determine the area of the parallelogram defined by each pair of vectors. P is 638 and Q is 335. So we need to find out the cross product of P and Q. It's going to be P2Q3, P3Q2, P3Q1 minus P1Q3, P1Q2 minus P2Q1. P2 is 3, Q3 is 5, P3 is 8, Q2 is 3, P3 is 8, Q1 is 3, P1 is 6, Q3 is 5, P1 is 6, Q2 is 3, P2 is 3, Q1 is 3. So that will be 15 minus 24, 24 minus 30, 18 minus 9. So that will make it as negative 9, negative 6, and 9. And when you want to find the area, it's going to be the magnitude of this vector, square root of negative 9 squared plus negative 6 squared plus 9 squared. It's going to be 81 plus 36 plus 81. 81 plus 81 plus 36. So it's going to be 198. Square root of 198 is 14.07. Now let's find out the area of parallelogram for this one. That's easier. It's going to be u dot magnitude of v times sine theta, which is 32. That will be 43 times 27 times sine 32. 43 times 27 times sine 32. That make it as 615.23.